Yes.
Yep.
I think I left my binder.
Same.
I took
Get
it.
a piece of paper. Start writing notes.
Yeah, sure.
Then you can transfer to the other one. There was some shoulder. There are a couple extra ones, but there's not that many. So if you know exactly where it is and you want to run, you can run. But we'll be continuing. So. Okay. We'll start right away. We left off not. Oh, those of you who weren't here on the last day, they missed the genetics test. It is in the library, in the folder, waiting for you. You can do it during test prep. Now that you're back, please get that done ASAP. Darwin and Wallace's observations. We're starting the evolution section, so we started off with Darwin and Wallace. Darwin, who published a book and got remembered forever, and poor Wallace, who was the most famous one of his time, but didn't write a book, so nobody remembers who he is anymore. Evolution just turns out to be the simplest way of explaining it is an algorithm. Whatever manages to give offspring, those genes continue on to the next generation. So genes that allow an organism to have more offspring that survive, those offspring have now algorithmically improved in a way that they will also now produce more offspring. It's not about how strong, fast, smart any particular trait is. It's about how the combination of those leave offspring for the future. It's also not a moral law. You know, it doesn't. You're not required to have tons of kids. It's just that's the algorithm. Things that leave more children have children that leave more children, and then over long periods of time, we will tend to have more of those types of children. So nature selects by allowing them to live, which is the nice way of putting it. Natural selection is a bit like making a sculpture and carving away the bits that don't work. Most species that have ever lived most species are extinct. Most things are dead. Evolution runs on blood. Everything that doesn't work well just dies. There's no way that you personally can evolve. You're just hoping for the best. So it works on species. It doesn't work on individuals. It's not Pokemon, unfortunately. That would be really cool. Survival of the fittest is often the term that's used for it. What did I just press? There we go. Reproduction. So if you live a long and fulfilling and full life until you're 123, that is survival of the fittest, but you're not really providing any evolution if you never had kids. There's used to be a best-selling book called the Darwin Awards, in which they would give awards to people that removed themselves from the gene pool in a most spectacular fashion. One of them managed to win without dying because he sat on the hood of a car. You know those little icons in the front of the car that had like the symbol of the car? His legs were kind of wrapped around that. And then when the car braked, he kept going and he left two important dangly bits behind on the thing. So he managed to remove himself from the gene pool without dying, and won a Darwin Award for that. I tried to find an example where people didn't die. There's one in there, but most of them are things like they decided to go into a tiger pen and commune with the tigers, and then successfully remove themselves from the gene pool. Reproduction and inheritance. Oops. Now, there's a lot of traits that you may have. We use the word trait more generally that may not be tied to a gene. Humans have culture. and we can spread ideas that may affect your reproductive. Evolution won't really act on those. Those are spread through an entirely different way, and can also, there's a lot of things evolution doesn't really act on. Evolution can only act on genes. Yes?
And was it that, like, for example, birds put like only like 3, 4, maybe 6 eggs, but then frogs put like hundreds of eggs?
Different reproductive strategies.
That
So,
means that the frogs more successful, but they put, like, more often.
Well, it may make the frogs more successful. If you're laying eggs, and an egg can be a huge amount of resources. So what's the difference between a bird egg and a frog egg?
I mean, they're different, like.
Well, birds raise their young and provide them food.
Well, they raise their young. So a bird is a lot of work. Like if you got to raise a bird, lots of bird species are monogamous because they require two parents to take care of them. And a partner's not going to stick around if the other partner's cheating. So those offspring don't survive if you have birds that are non-monogamous. So they tend to pair bond and they both raise the chicks. If one of the parents dies, those chicks die. You need two parents. Whereas frogs, like, yeah, lay a bunch of eggs and then they take off. Like those little froggies are on their own. So their strategy is just lay a lot. And then all the birds that come and eat the eggs, all the fish that eat the eggs, they're just relying on, by sheer numbers, some will survive. So two different strategies to get the same end. Some will survive. Humans have a bit of that as well. If I can, now that you've asked that, let me see if I can find the graph. Now this is a graph a number of years ago I saw, so I made a really cool version. I'll see if I can. Oh, this one has a year. Let's see how well this works. And this would explain why in some places, like my grandparents, I have no idea about my great-grandparents. My grandparents had on one side, 11 children. I might be forgetting an uncle in there somewhere. Whereas my parents had 4. I've got 2. Next generation might be just 1, or maybe none. But there was a time in which healthcare was not that good. If you had kids, you'd be guaranteed, not probably, but guaranteed that 2 would survive, either to take care of you in your old age, or to ensure that you passed on. You would have to have a lot of kids. This is a graph of child mortality rates versus fertility rates. So how many kids are people having versus how many kids people die. And it makes a lot of sense. The places with the highest child mortality rate have the most children. Because if your children are likely to die when they're 1, 2, 6 months old, you're probably going to, hedge your bets and have a lot more children. If the infant mortality rate is quite high, like 10% is amazingly high. Because to be guaranteed to, you need now to have 4, 5, and 6 kids. Not probably, guaranteed. You want like 99% chance you're going to have at least 2 kids alive when you're older. Well, then you need to have a lot of kids.
Isn't it also now with the countries that are more developed, it no longer works well, whereas countries that are less developed, where it's like farmland and so on, it's like the kids will pay for themselves because they'll work on the farm.
Well, that's one of the reasons you want to guarantee to have at least 2 if they're going to die. One of the greatest successes of medicine in the past number of years has been the fact that infant mortality rates and child mortality rates have dropped. Everything went this way. And as everything went this way, the number of kids people had dropped as well. You don't need to have 6 kids if you're pretty much guaranteed that all of them are going to survive. And so for the first time ever, a few years ago, the prediction was that by a certain year, world population might actually start decreasing because of infant mortality rates have gone down. Parents just instinctively don't need to have, they don't want to put resources into having 6 kids if, two will do, 3 will do. We don't need to have that instinct. Before, a bit more like frogs. Now, bit more, you can have less. And it's really expensive to have kids. I mean, you have to send them to Brentwood. There's tuition every year. Eventually, you have to send them to university. Hugely expensive. That is, of course, a mandatory requirement. So you should start saving up to send your own kids here. Because right after you graduate, who's it? Mr. McPherson will be sending you a little letter in the mail saying, you've graduated from Brentwood. How would you like to donate to our alumni program and fund the next generation of scholars? We'll plug for Mr. McPherson there. Tell him I said it so I can get a raise. So different strategies. I think I mentioned the large male fish and the small male fish the other day.
The other day was like a month ago.
It's probably true. There's a species of fish. I can't find the picture. And there's there's sexual dimorphism, which is when the different biological genders of a species look really different. Humans don't have much. We have a little bit. Males are on average slightly taller. Most of it overlaps. But some species, certain sea lions and stuff, you can see massive differences. Often that means because their competition is different in between the two. So there's a fish species that looks like that. The males are massive, huge, and the females are these small little fish. And the reason they're massive is the males will fight for access to the females. So they'll fight for food, they'll fight for access. The males will patrol borders. They have their own area. This was studied for years, and they thought they understood the biology really well. One of the problems, however, in science is that often the bias of the researchers leaks into the actual stuff. So that's the way they thought it was. And then, as more non-male scientists joined the group, they noticed some details that previous scientists had meant. They said, not all those females are actually female. Some of those females are male. And what is the reproductive strategy here? How is this working? While the big males are off fighting, those little tiny males will go through and have sex with every female in that particular group. So sometimes it's good to be small, sexy, and fast, as opposed to be big, tough, and sexy, I guess. And they both had equal strategies. They both worked. So you can have different types within a group as well. And they looked almost identical to females, which was now that's a whole characteristic that they're looking for in a lot of other species. Natural selection is the driving force behind it's the engine that makes it work. If it wasn't for natural, so we need a selective process. Now, that distinguishes it between another type of selection. And there's natural selection. How else can you control what kind of animals you get? Yeah.
Selective breeding.
Selective breeding. So that's artificial selection, is when a farmer goes, you know, that cow gives a lot of milk. I'm going to make sure that cow has a lot of calves. And I'm going to breed that cow to this bull whose mom also gave a lot of milk. And then over time, we will get farm animals that look very, very different. So artificial selection had been done for a long time. Artificial selection was actually understood in Darwin's time. No one had thought of applying it to nature. And I think now it seems really obvious, like obviously the same process would work in nature. There's still a selection process going on. But it was really an inbuilt bias that had to be an intelligent process. But the environment itself, much like a sieve selecting certain types of sizes of coins or pebbles or anything, it just works. Things that don't have the right genes aren't going to survive. It doesn't have to be intelligent. It's just hitting a barrier. We did beaks on the last day in that little lab we did. Beak sizes not only changed to differentiate into different species when they went to the Galapagos Islands and the finches evolved all the different types of beaks, but you can actually see it change over time. The beaks will change to adapt to the food that they're trying to eat. And you can actually pick out dry years if you're measuring beak size over time. So if you were, this is now something they'll use. If you have, if you could pick up dead birds that are old and mummified through a variety of processes and can date them, you can now predict what the rain levels were in particular regions just by looking at how the animals adapted to that particular year. Because evolution is ongoing. You're changing and adapting yourself to the environment in the same way that a pond or a puddle, the water is adapting itself to the ground underneath. So we all have a selection pressure. I'm running out of room. A reproduction. Selection pressure is anything that affects the reproduction or survival of an organism in a population. If the world, for example, was beginning to warm and global temperatures were rising, then any species that couldn't adapt to that particular rise in temperature is facing rather extreme selection pressure. We are seeing warm species move up north here that have previously only existed south, and some species that would say go south for the winter are now sticking around. They're not seeing the need to leave. Our winters aren't quite as cold as they used to be. Some of them are surviving by staying here, which is now affecting populations there because that food source isn't going down anymore as well. We are sitting smack dab in the middle in one of the greatest extinction events in geological history, not human history. Species are disappearing faster per day than at any other time in history that we have ever measured. Even when the meteorite struck the earth and the dinosaurs died, that took a long time. Pardon?
What about like giant floods when those are coming through?
Yeah, because this is affecting the entire world. A giant flood affects what? You know, a valley. The biggest flood we know of in the world. Ooh, if I can get a
Wasn't
world.
it like an entire continent?
What is that? Someone's
Since
what?
there's like
It's
massive
population.
There was one time where they believe a barrier broke, and I can't remember which sea in there flooded in, and that's maybe responsible for a lot of flood legends, because it was massive. But again, what's that? Area that big on a place that. Most things, that even the meteorite struck the Earth, it wasn't days, it was decades, and species slowly changing. Right now, we're moving into environments and we're killing off habitats, and the world is getting warmer. It's becoming very difficult for a lot of populations. We've gotten a little nervous lately because people have noticed that the insects are disappearing, which has been a goal for a long time because they eat our crops and they eat our food and they sting us and they're kind of irritating, but they also feed a lot of things. And if they're disappearing, we're starting to get a little worried as well. So, underneath, let's go with types of selection pressure. Competition within a species. You go to the dining hall and you see the last piece of dessert, and then someone just ducks in front of you and grabs it. Competition within species. Competition between species. You're in the dining hall, you see one more piece of dessert, you walk up, and a grade 8 duck ducks through and grabs it. They're not even real students between different species. Not entirely sure the human. Grade 8s aren't real students. Grade 9s are, but they don't count. Everybody knows Seasonal variation. You're sitting, it's warm, it's lovely, and all of a sudden everything starts to get cold. Your environment will, in many places, vary quite a bit depending on the time of year. That's a selection pressure. All the poor orcas who can no longer hunt for seals anymore. One of the ways that orca, have you seen what's it called, wave heading by orcas for seals?
When they slap
They
the
just
tails.
slap.
Not slap the tails. Yeah?
Did they like
You make a
launch them in the air to kill them?
Orcas do a lot of things, so yes, they do that. It wasn't what I was thinking.
Like swim synchronized so that they make like waves.
Yeah.
Like break the ice that the seal is in. So like the seal falls to the water and they like.
And then they chop up the seal. Seal's on an ice floe, and then they do that, and now seal on water. Haha, you thought we couldn't reach you. We could, except ice floes are all melting, and so the seals are staying on rocky shores. It's a little harder for the orcas. So orcas are facing a loss of their food source.
Don't dolphins do that? Like shower.
Dolphins are the most evil mammals probably known
Don't they
to
like
the
spin
world.
in circles and make like little dust clouds around a colony, their family of fish or whatever, and then they'll eat them?
Sure. I mean, I haven't heard it, but I totally, yeah. Dolphins are smart. Yeah.
I heard that like dolphins, like they also like use this one like pufferfish to get high or something.
Oh, yeah, I heard that too.
Yeah,
They
they
said
do.
turtles do as well.
They
'cause
play volleyball
jellyfish.
with it. They
Yeah.
play volleyball with the
The dolphins will get high on drugs, rape anything that moves, and torture members of their own species for fun if they can find one. They are not good things. If you see a dolphin and it rescues you, you need to question its motives. We also have a lot of stories of sailors being rescued by dolphins. And a biologist pointed out we actually don't know what they were doing because we don't hear the stories from sailors who were pushed away from shore by the dolphins. It might be that the direction they push you is random and they're just playing with you because that would actually fit in with dolphin behavior. They're mean. Seasonal variation. Oh. And then, of course, invasive species. You've got a nice little environment, everything's in balance, you know what to eat, you know what eats you, and then this weird toad comes up from somewhere else and just starts taking over everything. That is a brand new selection pressure. Let's see, how many people we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yes, question.
What does it mean to be like an invasive species?
A species that would normally not be indigenous or native to the region, and that gets there either by accident or humans bring them. Australia is the poster child for bad decisions with invasive species. They brought in, I think it was rabbits to keep down grass, and the rabbit population exploded. So they brought in another species to hunt the rabbits and ignored the rabbits. They brought in a virus, no bacterium, to eat the rabbits because it would infect the rabbits. It turns out it ignored it in favor of another and did like, it just took over everything in Australia. Australian mammals are a bit strange because Australia split from the continents before mammals had fully evolved to the present form everywhere else. So as you know, most likely that Australian are non-placental mammals in that when they're very small embryos, they will actually, well not embryos, larger than that, will crawl out and then go into a pouch in many cases and finish their development there. Whereas in other placental mammals, when they're done growing, they come out and they're fully baked, as it were. And it turns out if you put them in competition, placental mammals usually just knock non-placental mammals on their ass. Our reproductive strategies are a bit faster. So to protect the regular species there. And it could be questioned, why are you even bothering to protect them? If they're no good, they're no good. let the invasive ones come in. Often what happens, invasive one comes in, it explodes in number because it has no predators and it can eat whatever it is that's in plentiful supply. It eats everything, and then it mostly dies out, and a ton of species are gone, and that whole ecosystem just collapses. Now, that will fix itself over 100,000 years, but in the meantime, humans are going without food, shelter, forests, and all the things that are there, so we want to try and prevent that from happening. Okay, what I'm going, there's about 16-ish of you. Get into groups of 4, because I gave you all of these without examples. You can come up with 2 types of examples, an actual example involving animals, or an analogistic example, like I did with the grade 8s and grabbing a piece of cake. Within species, between species, seasonal variation, organisms introduced from elsewhere. I would like some groups of 4, please. And I think I should mix you up. I don't have attendance yet, so I'm not going to use the app thing, but just remember your number. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. All 1s go over there. All 2s go over there. 3 and 4. 1, 2, 3, 4. Moving around, and I'll take attendance.
Okay, where does
You can sit on chairs. You're allowed to. Timmy's here, Ben's here, Jonathan is here. Jonathan, yeah, there he is. Ariel is here. I swear I saw her. Yeah, there she is. Zoe's not here. Lisa's here. Felix. See? I want an example. One example for each one. Pick someone, have them write it down. If you're the one they picked to write it down, you're not the one that has to speak.
Oh, I have invasive species. So also like there's a bird all the houses are like competing.
Jude, Zane, Matthew, William, Kay, Alejandra, Ferdy, Karen Porter, William Wren. He's not here. Naomi's here. Hugo's here. And Sahir is here. Well done.
Yeah, it eats pigeon. Yo no utilizo la contorna, la voy a utilizar yo.
Why is that? There we go.
Entre la misma especie. Entre especies.
Great example. So competition between species.
Competition between species. Or house events.
Compete to mate.
Within species.
I think it's like
Compete. Yes.
yeah.
Find an example. So I didn't say what they're competing over, and I didn't give an example of it. So what are the things? I'm hoping with 4 different groups, we can come up with some.
Seasonal bird.
they share great number.
Seasonal.
Yeah.
But isn't it like if you're so
No,
comfortable?
yeah.
No, I mean like
All the time. So if you do like crowd AX,
surrender
and
prices.
then EX.
And what's a lot?
I got an invasive species.
Seasonal variation.
It's called Kotona. It's like C.
For seasonal?
well they change your
Maybe like the first one. Like the grade
Yeah,
12.
what doesn't do?
Grade 9s.
is the old bears.
In the winter, it's easier. Or,
Well, no, within
The
species.
crabs.
You know
What do they
how-
crabs use? Like
They came
snake.
along like what?
Yeah.
That's it.
UFC's
the what?
Oh, like the big
Yeah,
crabs.
what does it do? Like,
Like there used to be a whole
I'm not yours.
Question. Now that you've been thinking about it just for a minute, what kind of things do they compete over in a species? Yep, one. Give me one. Food. So this would be food. What else?
Shelter.
Shelter. So places to live because they're going to live in the same place. Yeah. Mates. Now, which ones would they have in common between species? Yep. Food. Would a dog and a cat? So, different species, do they have this, would they compete for mates? Unless it's very exceptional, weird circumstances. I mean, I could imagine a science fiction-y scenario. But mates is not going to be typically a huge draw because they're going to be looking for different things. But food, definitely. And yes? Territory. Shelter. They're going to live in the same kind of places. Spiders like living in your homes. They're competing with you for that particular shelter, and yet you kill them. How dare you? If you ever see a spider and it's spun a nice little web in your house, and you take that spider and you put it outside, you have killed that spider. Because that spider is a house spider and has actually evolved to live in your house. It is no longer an outside spider. It doesn't know what to do in the rain and the cold. However, if you see one of those big ones just crawling around, those are wolf spiders. They can go outside. They're hunters. They're probably actually worried about the lack of food inside your house, assuming you don't have bugs everywhere. Seasonal variation. What kind of pressure is that going to put on you? Food. Food may drastically change.
Different temperatures.
So environment. Temp is just a good example. Yep. Shelter. I mean, famously, bears deal with it by just going to sleep for a long time. They don't really go to sleep, but they basically just become grade 12s on senioritis. And then organisms introduced from elsewhere can be everything from here. Okay, come up with your examples.
What about like polar bears?
Oh, we got the examples.
What about polar bears?
Or like the
or what about like how
You're talking excellent.
temperature
And I just realized I had an example.
and then the polar bears like
Where's my? There it is.
Timmy, do you want to take out an example?
okay.
The last one?
Organisms introduced from somewhere else.
No, that's not it.
Like humans going into a jungle and like messing with the monkeys
shoot.
And that one big metal one.
Exact. To be album or female, it's female.
Right? Is that it?
Yeah, I'm so confused about the third one because I would pronounce it not make sense. Like that all.
It means like when animals go into that hibernation, like when they move, like when birds migrate from like different countries.
No, I mean, I'm talking about her example.
Okay, wait, okay, no, how about, like, right, and then you go, like, from,
Where is it?
No,
I don't remember seeing that.
yeah,
You come up with it.
the people who go on the school trips
Oh, yeah.
to Eswatini, they like,
It's supposed to be
Yeah. I was thinking
You don't cost them.
yeah, it does. Give them like that.
Cause like the construction.
No, it's like my body. Here.
Isn't it funny?
The Bay State ones are good.
We are basically banning glasses in this public. I'm really on top.
Julian has really nice openings.
Oh, really? Where did you buy Ash?
I think I will next for.
Oh, where can I go to see these areas with sports glasses?
That would be funny though.
I thought I saved an example, and it turns out I may not have put it in the right spot. Okay, I'll find it later. I can't find it in 2 minutes. It's not really fun. Okay, let's start reverse. Group 4. Give me an example of competition within the species.
Prides of lions fighting for food.
Which one? Sorry?
Prides of lions fighting for food.
Prides of lion.
Like, the males will fight to see who can be like the leader.
Yeah. And so they anything with a territory is going to be fighting over food and shelter because that's a particular area. Group 3, competition between species.
Hyenas and lions like fighting over food.
Ooh, we have a lion popularity.
Because they both eat kind of similar prey in their ecosystem.
Yeah. It was once thought, I mean, originally biologists, like, obviously the lions are in charge. They're males. And then later on, they were like, this doesn't make sense. Because the lions, by the way, the male lions don't do very much. They're not the main hunters. They're kind of lazy. Why do you even have lions? And it turns out they're just the security guard. Hyenas require something to keep them away. And so the male lions are mostly there just to be protection against hyenas. They compete over the similar food quite a bit. Group, this would be 1, 2, seasonal variation.
We got mosquitoes, for example, because they like just disappear in winter or die, and then they come like back in summer.
They go to the river.
Yeah, do you know what happens to them?
They go to the river.
I don't think mosquitoes can survive winters.
Well, but we get them back.
They lay eggs in like swamps and ponds.
Yeah. So they just don't hatch when so they have changed their reproductive cycle to fit when there's the most food. And so, yeah, there's a part that survives, the eggs in the areas. If you want to reduce the amount of mosquitoes in your place, dump out all the buckets of water in areas that hold water. If you've got an old tire swing hanging from something, gathers water, the mosquito breeding ground. They lay their eggs in all those places. The more of those you can remove, the less mosquitoes you'll have. So seasonal variation on how many you have, because they've adjusted their cycle in order to have the most of them around when there's the most food. In the wintertime, there's not that many people to bite. They tend to stay indoors. Organisms introduced from elsewhere.
So like, when the humans like cut down all the trees, they like remove like a lot of species like place to live.
Yeah, humans could be considered the most invasive of species. So much so that it's hard to come up with a singular example. But yeah, when we go in and take it, we change the entire environment and kick everybody out. Per poor Sophie the squirrel, who was living in a place and just had her home cut down. Any other examples? Specific species? Do you know any local to the area that you have to be careful of? I think there one.
There's the European green crab as well as the
European what?
European green crab. As well as
Green
the
crab?
Blue crab. They took over like all the hermit crab species around here, killed them all off.
Okay. Others?
Broom.
Broom. Ugh. Scottish people. No, it literally on the broom on the highway. They give the yellow flowers. Awful for if you have seasonal allergies. They're one of the main components. They give it to you. They grow in everything in their ditches. They don't have a natural predator, so nothing eats them. They were brought by. We actually know which Scottish couple brought them into whatever time and planted them in their garden. And now it just grows everywhere. Oops. Yep.
There's this green bird that's from Argentina. It's called Cotora. And just someone brought. This is what it is believed. Someone brought them to like Spain, and they just started reproducing massively, and they're just like moving
Everywhere?
parts of.
How do you spell them? What are they called?
It's C-O.
It's like a monk parakeet.
Yeah, it's from Argentina, and it's like moving through all Europe.
What type of bird is it?
It's like I don't know how to speak it.
It's green.
It's green.
There's
Oh,
like
monk parakeet is so cute. It's
like-
moving through everything. I like monk parakeet. That's easier to say.
yeah, they're killing like pigeons because they stole the food.
Yeah, it's like starlings here. Starlings were a bird from England. People brought them in cages because they sing pretty songs, and then they left. And now they have huge flocks that have been on the island and BC and everywhere. They eat the food of the other native species, and as I hate them, they like to roost inside barns and they shit over everything. And they get huge numbers, and there's not much you can do about them. They're not smart like crows, so you can't threaten them. If they see dead members of their own species, they're like, cool, and they might even try to eat it. But with a crow, you show a dead member of its own species, crows will go, you're a dangerous person, and will get upset and like leave the area or try to attack you. So yeah, that sounds, because this is probably just a small bird that just eats everything. Yeah. Any cool examples you came up with before we move from here for any of the ones above? Because we got quite a lot for the last one. Yep.
Would might sound kind of stupid, but would the UFC count as competition within species?
UFC?
Like the MMA, because they like compete for glory and one.
Sure. Now they're both wrestling, right?
No. It's like
Well, UFC and is this wrestling?
No.
MMA? Oh, 'cause it's all wrestling. They're all just bodily contact things. So, did you say that's within species or between species?
within species, because it's like a human against human.
Human against human. So I thought you were doing like an analogy, like these are two different programs, and so you can be fans of one of them because they're both drawing from the same pool of fans,
Yeah.
right? So
But I think gladiators.
UFC and what was the other one? MMA. As an analogy, looking for viewership, I guess.
Yeah.
Or were you saying literally?
Yeah, like
Glory.
defined as
Glory.
Because literally, people aren't dying in these, are they?
You could.
You could, I know, but I mean, you could die in hockey too, but
Yeah.
we try to make sure that doesn't happen.
Yeah.
Because most variations of human competition don't tend to be that obvious unless we're like talking actual war and people are killing other people. But you could certainly talk about mate selection. Is it better to be in MMA or UFC if you're trying to show off how fit you are to other people? Because they're both very similar within the same type of thing. Which one has the larger cachet?
I was just gonna say, like, what about the gladiators?
Yeah, would that be enough of a selection pressure? Now, definitely,
Because they're killing each other.
they didn't kill. Interestingly, they didn't kill each other very often. Reports from movies about how often they died are greatly exaggerated, but they were like. It's actually very similar to UFC, MMA, wrestling. It's actually more similar to like traditional wrestling. Can you smell what the Rock is cooking? Type of cartoonish almost rivalries because it was entertainment, and so certainly being a superstar and in the entertainment business, you could talk about which area you can go into to increase your chances. I did once listen to a group of students deciding their entire future life educationally and what courses they were going to take into university, as in what area they were going to get their bachelor's degree in, based on the gender ratio of students in there, so that they could have the most probability of finding a mate. And I'm like, that's not how you should choose what area you go into to work in for the rest of your life. And they're like, no, this makes sense, Mr. Neufeld. And I'm like, no, I think you need to like get outside more. Okay, I think that's enough for that one. Thank you. Return back to your spots. And where's the Google Classroom? You may now. Is it not out? What just happened? You can take out your computer. You get like 5-6 minutes. We are in April. I'll give you 5 minutes to play the Peppered Moth natural selection game, because that's going to be my next example. So I'm not going to do it for a long time, because I think it makes the point relatively quickly. The point of the game is that the trees in the particular area in England were light in color. They were birch trees. And moths had developed, with the exception of some natural mutations that would occur once in a while, into 2 different colors. The typical light-colored moth. And then occasionally you'd get this melanic morph moth that was completely dark. It had a lot of melanin. And it was a mutation that would happen spontaneously every once in a while, in the same way that we get albino species every once in a while. But it was always low in numbers, because if you put that on a light tree, it's really easy to see, and birds would eat you. Everybody looking at this, how many moths are in this picture?
3, 4, 5, 6.
Right, because there's that one that they crossed out, but there's that one there, and there. Whereas once the Industrial Revolution happened and smoke started covering, soot started covering the trees, the dark moths had an advantage and the light moths all of a sudden found themselves being eaten.
They just took one moth and copy pasted it.
Hmm?
For the bell curve there,
Yeah?
they all have the same specific spot, but it should have variation between where the lines are. It's all the exact same lines.
Oh, yeah,
There's
because,
just
you know,
variation.
you're not going to spend time drawing that. They're going to copy and paste
After
that.
they take a real picture of it, no.
No, we're going to copy and paste
I
that.
got 42 moths there. That's pretty good.
So eat those moths. Are you eating the moths? Playing the game, eating the moths?
Oh.
Okay, that's just unfair.
That's hella cheating here. Get out of here. I'm so lost. Light and moth colored more.
And then you can see the population below it on your simulation and how that changes. Now, as a human, you can do artificial selection. You can be like, no, I will break the bounds of this game and I will only eat light colored moths against light colored trees. And you can see how that would change it. Hold up, where did my version go? Oh, we even have sound.
How did you get 66? Oh, you're funny.
Oh, dude. Oh, actually, that record face.
There's 92% of the label.
No. I got 66, man.
Okay, how much you get?
How many did you get? I got 9. Dude, I got 66. I like the dark one. I did both. I got
Now, what do your grass like look below?
Pardon?
What do your grass like look below?
They go
There you go.
from, like,
You can see the light colored moths are dropping and the dark ones increase dramatically.
67 good.
Oh, so do I gotta keep them both kind of level?
No, you don't have to do anything. Your only job as the bird is to eat moths. And that's providing, now what is that, what is the bird in this scenario?
Predator.
It's the predator. It's providing
They're eating.
a
Composition?
it's not competing because we missed one on here, and so I thought this one would be a great one. Competition between species. Yes, the hyenas and the lions compete over food, but when you have competition between species, that's often when you get predator prey. You don't often get predator prey within a species. There's not many species that eat their own. Whereas now we have a competition between species. The moths are literally food, so the bird is providing a selection pressure. So the magic word I was looking for was, those birds are a selection pressure on the moths.
I got 66 too, bro. Get out of here.
And while you're doing this, nope, not that one.
Wow, you just played the cool bird moth game.
Where is it?
Kieran,
Where's
can
my
I
little
call you
bird?
the high score, bro?
While you're doing this,
No, this is
take a glance down at the graphs, and you can see, depending on the one you're at, what happens. And so my light color, I was on dark tree, so my light colored moths got eaten first, and the dark colored moths in the population adjustment to that pressure. So you can see how changes can actually happen quite rapidly. Oops, I didn't change the species.
Dude, I'm at 12 seconds and already at 50.
Are you having fun with the other ones?
Mm-hmm.
Excellent.
Leaving the mouse quicker than that.
How to beat the high score?
There's a high score.
No, it's just like the mental high score. The classic. There you go.
Mental high score.
I'm getting 100. Oh yeah, 65. Come on, give me 70. Give me 70. 69. Let's go. Thanks, dog.
Okay, put it away. That was 5 minutes. Actually, a little longer. Close your computers. Put them back in.
Right, so I love those users.
Is there another one in there I missed? I thought there was 6. Where is the other one?
Bro,
Hmm?
I don't think there's 6 more.
movies past Fast Furious 7.
Is
One
there
is
one?
circled by a red dot.
Is there one where it's open?
No, that is not. No.
I'm gonna say it is.
No, it's not.
Yeah, it is.
No, it's not.
No, it is.
It's not.
I'm gonna leave it circled. We'll see how many people know this. Okay, notes back out. So you can see a selection pressure can provide a fair, when the environment changes and the selection pressure changes, the population will adapt to it. And it doesn't adapt by going, oh, look, I better change my coat to a different color. It's just all the ones that were light are the ones that you ate first because you could see them against the dark soot-colored trees. As the population changed, then at the end of the Industrial Revolution, once environmental controls came out and then said, hey, maybe we shouldn't be putting as much soot out in our smokestacks, and we started filtering more of the factories, the trees went back to the regular color, and then the population shifted back again. And so the birds provided that selection pressure because, of course, it's a lot easier to eat something you can see. We've got a variety of experiments that we have been done and examples that we've seen over time. This one is, I find particularly interesting to me. My background is biochemistry. They've taken E. coli, which is a type of bacterium that lives in your colon. Lives in many species colons. There's a variety of them. This is the one if you're using natural fertilizers on crops and you get it on your lettuce, and if you eat it, it's from another species, it can invade your gut and really hurt you. But you have this living inside of you too. So what a microbiologist has actually been doing an experiment in which they have thousands and thousands and thousands of generations of E. coli just evolving. And what you can do with E. coli is you can freeze it and then keep it. So in addition to just it reproducing all the time, they have samples of every single generation. So they can go back in time, essentially, and regrow a previous generation. Some mutations have happened multiple times in different strains. They're like, oh, this mutation seems to be very common. One of the ones that happened was that E. coli developed the ability to digest citrate. Citrate was in there to make certain antibiotics work better. So it wasn't there as a food source, and E. coli is defined as an organism that can't eat citrate. It's not part of its metabolic cycle. And so a spontaneous complex mutation happened in which it could. And it would be a bit like if there was a generation and deer turned feral and started attacking humans because it liked the taste of human flesh. Just completely shift from grasses to humans. That was a bit like the change when E. coli goes from normal sugar to digesting citrate. It was a huge change. Very rare. It has only happened once, and they were able to track every particular species of it. Useful because E. coli is simple, it reproduces rapidly, so we can do multiple generations and see how evolution occurs. It would be much more difficult to do that with humans. So interesting things are happening around the world. We now have nylon-eating bacteria in the waste ponds of nylon, a factory essentially. Bacteria has grown that actually can eat nylon. I live in, I wouldn't say fear, but I'm a little worried for the first day that a bacterium figures out how to easily digest plastic. Now, great, all our plastic will now decompose. Fantastic. Can you imagine having to spray your car every day in your house with antibiotics to make sure it doesn't get digested?
Well, very quickly become immune to the antibiotics.
Once something can eat it, the whole point of plastic is that it lasts and it doesn't decompose. All of the parts made of plastic will now just turn into sludge. And so that's a little worrisome. A similar thing happened in Earth's history. Plants evolved a very strong structural element called lignin, and it's the part that makes plants really strong, and they snap when you crack. Allows trees to grow to huge lengths, and nothing on the planet could digest it. So the entire planet was just covered in dead vegetation. This is where we got our big coal beds, because plants would just pile up and get buried, and that would eventually turn to coal, because nothing could digest them. They didn't decompose. So essentially, nature evolved a waste that it couldn't deal with. And there is actually evidence at one point that there was a fire that covered the planet. There was so much vegetation that a fire started that was large enough that jumped and did entire continents. We can find ash layers like that. And it's where coal comes from. And then one day, a fungus developed the ability to digest lignin. And at that moment, we can't make coal anymore. Coal doesn't occur by a natural process because nothing gets buried like that anymore. Because it didn't. Once something evolves to eat plastic, we might be in trouble. There is a London underground mosquito. We think it came from a particular species that likes dark caves. So it's not a completely brand new mutation, but there's some evidence to suggest that this particular Egyptian mosquito has adapted to not just the London underground, but subways. Got a lot of people there, safe from a lot of different predators, and it doesn't do well outside of subways. There's evidence that there is a type of fungus. Question? There's a particular type of fungus has been found growing in Chernobyl. Where they're listed in another one. Maybe it's further down. It uses the radiation given off to directly power its metabolic processes. So it eats radiation. They're looking at it as a possible way to make shielding for spacecraft. One of the problems with going to somewhere like Mars is not just getting there, but the fact that the whole time you are absent the protective effects of our atmosphere. So you're exposed to a lot of radiation. Your spacecraft, in order to protect you, would need to have thick lead, and that would take way too much fuel. If you have a species you could coat it with that would eat the radiation, provide protection by absorbing it, be a lot lighter and a lot more efficient.
What if you make using mold protected the longer you're in it?
Pardon?
Like if you're in a space, the longer you stay and you cover it out, the longer.
Wait, come again?
You just say it's just like
Yeah, like
Oh, because it would grow. They'd probably want to grow at their minimum levels before you left, but maybe, yeah. Yeah, maybe a bit like, I'm not talking about oxygen. They'll provide more to keep it growing. And you're providing the CO2.
shut the front door.
Shut the front door?
Yeah.
What's going on there, Zane?
Very passionate argument about
And what's the argument?
I'm saying it's like, isn't it like they don't use they don't use artificial intelligence.
Yeah.
Because
There's a robot war.
so they use like organics. But is it
there planets that are still
They
taking over,
specifically, basically
So
bred
clutch.
humans to act as human
Yeah, is
companions.
that a
Yeah,
shotgun?
because
I mean, I
they
watched
had-
a little bit.
The lore is that they had like a robot
But they still
uprising,
do
and then
have,
it was
like,
100 years
some
war or something.
computers.
Yeah,
They still do have some.
Little girl has a
but they're not,
shotgun.
but they're not
Very
thinking
cool, man.
machines.
Yeah.
Yeah.
So cool.
So even like they're like,
Yeah.
to the point, like there's not even calculators. They have mentats. Mentats do all of the calculations.
Right.
So that nothing that is, so they will have machines, but they're all switches.
Right. Well,
Yeah.
no, the holographic screens in some of the control rooms.
But yeah, he never explains how's that work because that would require
They did in the books
computation.
either. Yeah.
But on the other end, like a camera just takes in an image
yeah.
and then generates it the other
But,
way.
but the thing
There's
is,
nothing calculated.
but they're saying that they have lots and lots of image things that are taking the image, and then it combines all those images together. It would have
Yeah.
to think, okay, so it doesn't mess it up.
Well, it may not. Like there's
Like it wouldn't be like advanced. Like it would be like what we could do today. It's just combining imagery.
unless it's like old TV cameras had no computation.
Yeah, but an old TV camera, you're only taking
Broadcast.
one. You're only taking one and broadcasting it straight.
Yeah.
This one here, you're having to take like 60 different cameras and you're combining it into one footage.
Unless it just does
and
it
it's doing
like,
it automatically.
but that may just happen because they aligned it properly. So it all does that, hits the sensor right, and then the other end just
But they're
duplicates
saying
it.
that like they have lots of satellites. The satellites would have overlapped, guaranteed.
Well,
but-
I don't know how they did it, but I do know it is lore that they don't
Yeah.
have anything with computation abilities. So,
I know it's
assuming that
part
is
of
a
the lore,
sacred
but, like-
text, sacred text, it
Yeah.
can't be wrong.
But at the same time,
No, can't be wrong. Hello, Goose.
Yeah,
How was your break?
it was good.
Good.